afternoon, everybody. So my name is Andreas Petersson. I'm going to switch to this stage because I think here is the much better audience, and therefore, because also I have a quite technical topic. It is about the challenge of integrating a blockchain backend system into an existing enterprise environment. So maybe is everybody familiar with English? Is everybody fine with English? Yeah, sure, good. Maybe to set the stage, I will talk a little bit about my background, where I come from. So I've been in the blockchain industry for a long time. I founded Bitcoin Austria in 2011. So I'm located in Vienna, Austria. Bitcoin Austria was one of the first formal organizations, even before the Bitcoin foundations or other things, where we made regular meetups and spread the word around Bitcoin and blockchain technologies. In 2012, I jumped into blockchain full-time when I worked on the Mycelium wallet, which is a popular wallet for Android, and we had a headquarter in Vienna. Then I co-founded a startup called Minebox. It's about distributed storage. We built a physical product and sold the business in November 2017. And now I'm really focused on producing software and services with capacity blockchain solutions also based in Vienna. And what do we do? So we are specialized on smart contracts. With a big focus on the distributed storage aspect and on off-chain transactions. And we deployed a couple of solutions already where companies approached us. They said we need specific problems solved with the help of Ethereum, with the help of Bitcoin. And we launched around 10 solutions already where we built backend systems. Some of those were also in connection with ICOs. So we also went and assisted 7 ICO projects, and most of them were quite successful. The biggest project, or the most well-known project that maybe some of you have heard of, was the HeroCoin project. It's a decentralized esports gaming platform where we also built the backend systems, and they are currently in a live beta. So why would you integrate a blockchain into an enterprise system? So a typical enterprise system contains a number of components that interface with your internal systems, interfaces with your customers, and interfaces via traditional web service backends with different other systems. It's actually, a blockchain technology can introduce a whole new layer of data and a new type of abstraction into such a system that makes it easy and possible to audit the system from an external state and to interact with the system through a new means, for example, via transactions. So this also means you can easily interact with your business without setting up specific trust with your subsidiaries. If you are doing mergers and acquisitions, it can be very interesting to have multiple deployments with multiple teams that don't necessarily trust each other yet. Maybe they are just recently came together to work with each other. And this additional data layer enables a couple of interesting use cases. So every time what you do, when you go to the drawing board and you try to build a blockchain system after you have chosen your preferred technology stack, which can be a challenge in itself, the question is, how do you really model the data that you're going to exchange? And I can tell you this sounds very exotic and new because you have to deal with new languages, new transaction semantics, and so on. But actually, from a practical perspective, it is very, very much like modeling a database and modeling the actions that people can perform on the database. Just that you have to think about, well, these updates are really going to the world, and everybody will be able to read it, at least everybody participating in the system. So you have to think about this like you would model a database with some additional restrictions. Mistakes can hurt a lot more because every error that you make is potentially much more costly. You cannot simply run an upgrade on these data models. And of course, yeah, the transaction semantics and the costs can also be much different. So every update of data in the operation will cost you a little bit of resources. And for bulk data, where you're really talking about very large amounts of data, there is no universal solution yet. So this is the very interesting topic that we are mostly working on, to take large amounts of data like image data, backup data, virtual machine images, and trying to distribute those types of data and connect them to blockchains and secure them. And this is the topic of open research, where I won't go too much into detail. But basically, for small amounts of data, there are some really interesting solutions out there. Once you have built your system and you deployed your smart contracts, there is the challenge of really bringing this into production. And we have tried out a few things, and there is a very simple pattern that emerged, that you have your existing microservices architecture, your existing REST interfaces, and you simply add another new microservice to this kind of software stack. This usually works out quite well. What you need to be aware of is, in many cases, you will need a two-way communication to and from the new blockchain microservice, so that both events coming from the blockchain and events triggered by the users can both be processed. So designing it one way only doesn't work. So in many cases, in some cases, we saw that this leads to an architecture where a message bus can be quite beneficial. Or you simply have, if you have a monolithic API backend system, this monolithic API backend can also provide an API. And what is a little bit problematic, where I see that there is still some best practices needed, is in the case of consensus failures. So it can be the case, and it happens from time to time, that you encounter situations where the blockchain proceeds in one direction, and then the blockchain gets reorganized, and some of the transactions are being reversed. That can happen in Bitcoin with the uncle blocks. It can also happen in Ethereum. In very extreme cases, this leads to a certain state of the blockchain that is later then reversed. And this is really, really hard to test. And testing this properly will probably consume a majority of the testing resources that you have to put into the project, because it's relatively hard to replicate this kind of failure mode, and it can introduce very bad inconsistencies. When in doubt, of course, you should always have a single data source that is authoritative. So if you replicate data, for example, data that is put into the blockchain on one place, and you replicate it in the database for quick lookup, it is most likely not a good idea to do that, because if these two sets of data could now in theory diverge. So if you deploy a blockchain system in one microservice, you will probably always want to have that service as the authoritative source for the data. So what are the challenges in doing this? So when we deployed this system, this was quite new for us as well, and we ran into a couple of problems that were not anticipated. So first of all, it is a significant overhead to maintain your own node, especially in the startup phase. When you start it up the first time, it can take a few days to get this system running and into a state where you can start to query it. Once it is actually running, it's not a big deal to keep it up, but the initial synchronization, if you have ever done this, can be quite cumbersome. Then, of course, uptime requirement also means you want to make sure that you always have a failover node that is already synchronized, that if one node fails, the other one can take over. So from the security requirements, it is quite obvious that once you do on-chain transactions, you really must make sure that your keys are well protected in any case. So this applies the same to API keys at Amazon, at some other backend keys, but you really want to have a good separation between production and test, because when these keys are being compromised, you will have a big problem. On the plus side though, if those keys are compromised in a significant way, you will notice it quite quickly, because if you have a hacker breaking in, stealing your private keys, and you have some cryptocurrency stored on that key, they will probably empty it, and then you will notice it quite quickly when things go wrong. So I already talked about the reorganizational aspect, so that can be quite tricky to manage. If you want to get some good exposure here on how this can potentially impact the system, you should definitely use a testnet that is very close to the real mainnet version. So if you are using Ethereum, then I would recommend that the testing phase should always be performed on the Robston test network, because it most closely resembles the real network. The other aspect is that something that you don't see in theoretical testing is when you perform transactions, they usually come very orderly one after the other, but in the real world all the transactions done by different actors come in at asynchronously at undefined times. So you have to be careful if you trigger something subsequently, that your backend systems keeps track of when it's doing what, specifically so the nonce management for keeping up with the transaction counts. Yeah, there is the ecosystem in the blockchain space is still relatively new. So if you are relying on third-party services, I would be really, really cautious. So we had a couple of projects where we relied on the data feeds from specific providers, for example, CoinMarketCap. CoinMarketCap had a great API. You could get a lot of data, and suddenly it's no longer available because they are introducing a for-pay API. So relying on these third parties is often not such a great idea, because it will basically, it's always a huge liability risk, and those services that are out there today are not guaranteed to be out there forever. And one of the biggest challenges in practice is this end-user key management problem. So can I ask in the audience who has any type of cryptocurrency on a phone or a desktop or anything? Please show some hands. Who is anything like that stored on their machines? Okay, so and who of you is able, from those people who just raised hands, who is able to perform a transaction in the browser using the Web3 API? 1, 2, okay. So this is something that from a developer's perspective would be great if it worked today. But in fact, the practical fact is, from a usability perspective, this is many years into the future. This is not something you can expect today. So when everybody who is presenting the next CryptoKitties and the next decentralized exchange and whatnot, they all take this as a prerequisite. And I think that is a little bit too optimistic today. So we have as a developer, we have the obligation to make sure that not only the very advanced users who have the latest technologies available can actually use our applications. So what users really expect is that those kind of questions are taken away from them. And most people who go to a website expect, well, I'm logging in with my username and password, and then I can do all the things, because this is the UI pattern that everybody is used to. But in practice, it turns out this is really hard to do. So because this has a lot of downsides. When you store the private keys who do things on the blockchain, perform transactions, you have a great liability, especially if the keys are compromised. And also those users who are familiar with the crypto ecosystem will be quite skeptical if you tell them, just give me your private keys, we'll do something with them, don't worry, it will be secure. And also, as the last point, if you are in Europe, there is now the 5th anti-money laundering directive, which says if you hold crypto assets of any kind on your platform and you have the power to perform transactions on behalf of the user, you are suddenly treated like a bank. But we just wanted to send around some crypto kitties. We don't want to like be a bank here. But the problem is, from a regulator's perspective, this can be a very slippery slope. So you really have to move out the keys from your system to more towards the end user. So how do you do it? So obvious solution would be everybody should just use Web3, but users are really not into that. They don't know how to handle the backups. I'm sure if you tell a user to set this up, they will lose the backup of the 12 words. And it suffers from very poor usability, or rather the users maybe are not, they are not used to these patterns yet. And I would say personally, this has an even bigger risk of losing funds than the variant with the server-side keys, because eventually you will the users will simply lose the keys. So we came up with a proposed browser wallet hybrid approach here that solves basically all these questions, and we rolled it out successfully as part of the HeroSphere beta rollout, where users can use their play tokens to perform decentralized betting. So this hybrid approach is that the user generates a browser wallet, a wallet inside the browser by choosing a secure password, and they get enough entropy from a salt that is provided by the server. And recovery is possible by sending out an email. And all interactions with the system are done with JavaScript. So from a user's perspective, they get the best of both worlds. And it's just a little bit more work to integrate that. So I think this is like one of the many UI patterns that will emerge in the future, where we will see how this really works. So I would like to thank you for your attention. I hope I could give you some insight into how this is done in practice, and I'm happy to get some questions from you.
Thank you. And